Hello and welcome back. In this video we will start Chapter 5 with Section 5.1, and this chapter is going to be looking at multiple equations or multiple inequalities at once. So a linear equation, like we've seen before, is something in the form ax plus by is equal to c. And this is a linear equation in just two variables in x and y, although a linear equation could have more variables in it. We're just going to focus on just x's and y's in this video. Now that we have seen how to graph and how to solve linear equations, we can start considering systems of equations, meaning that we can have two or more linear equations. In this section, we're just going to focus on two equations at a time. So, for instance, this is a nice system of equations right here. We have 2x plus 3y is equal to 1, and 4x minus 5y is equal to 13. So this is just an example of a system of equations. What we're going to be concerned with is finding solutions. And what do I mean by a solution? A solution is just going to be a pair of numbers, so a value for x and a value for y, that satisfy both of the equations in the system. So we can check a couple of these. So for instance, we can have the numbers 2, negative 1, and we could ask, is this a solution to this system of equations? So let's plug 2 in for x and negative 1 for y. All pairs are x and y. So let's plug 2 in for x and negative 1 for y, and see if both of these equations come out true. So for the top equation, we'll have 2 times x plus 3 times y. When we simplify this is 2 times 2 is 4, plus 3 times negative 1, which is negative 3, and that is equal to 1. So the first equation, good. Let's look at the second equation. We have 4 times x, which happens to be 2, minus 5 times y, which happens to be negative 1. 4 times 2 is 8, and negative 5 times negative 1 would be positive 5, and 8 plus 5 is 13. So, yes, this is a solution. So, this is a solution. Let's try another one. 1/2 0. We can use fractions. So let's plug it into the first equation, which is 2 times x plus 3 times y. 2 times 1/2 is 1. 3 times 0 is 0, and 1 plus 0 is 1, which is exactly what our first equation should be. Let's look at the second equation. This is 4 times x, which we have as 1/2. Keep doing the same thing. Minus 5 times y, which happens to be 0. 4 times 1/2 is 2, and negative 5 times 0, well, that's just 0. So this will be 2. But the second equation was meant to equal 13. So even though it satisfied the first equation, it doesn't satisfy the second equation. So this is not a solution. So when you have a potential solution, it has to satisfy every single equation in the system and not just one or the other. So the question is, how do we find solutions? And there are two methods that we'll talk about. One is called substitution, and the other is called addition. Substitution and addition both work, and they should work every single time. And it's basically up to you, or whether the question says it or not, to choose which one you want to use. So for substitution, what we'll do is we'll solve one of the equations for one variable, and we'll substitute that expression into the other equation. This will make more sense when I'm going through it. But after we substitute this expression in, we will solve that new equation. Now we have one of the numbers, and we plug in that number to figure out the other one. So that was a lot of words. Let's apply this. So the first thing is that we want to solve one of the equations for a variable. And here I have 3x plus, this should be 2y, is equal to 4, and 2x plus y is equal to 1. So if I want to solve one of these equations for one variable, I'm going to see that the second equation is going to be pretty easy to solve for y. So if I try to solve the second equation for y, what will I get? I can subtract 2x from both sides. So if I subtract 2x from the left-hand side, those will cancel. And then on the right-hand side, I'll have 1 minus 2x. So I have solved y. I have solved for y in this equation. And y is equal to 1 minus 2x. So that's the first step done. I've solved one of the equations for one of the variables. Next, I will substitute this expression into the other equation. So y is equal to 1 minus 2x. So my other equation was this top one. So I have 3x plus 2 times y is equal to 4. But I know that y is equal to 1 minus 2x. So I can substitute this in for y. So again, y is equal to 1 minus 2x. So I plug that in for y into the first equation. Notice that I used the second equation to solve for y, so I'm plugging it back into the first equation. So what will happen here? Well, now I have an equation with just an x in it. Let's solve for x. So I will distribute this 2 here. So I've got 3x plus 2 times 1 minus 2 times 2, which is 4x, is equal to 4. I have some like terms, so 3x minus 4x. Well, that's just going to be negative x. Plus 2 is equal to 4. Subtract 2 from both sides, and I get negative x is equal to 2. Or x is equal to negative 2 after I multiply both sides by negative 1. So here is part of my solution. I know what x is. The problem is, I don't know what y should be. So in our list of steps up here, we solved an equation for a variable. We substituted this into the other equation, and we've solved for that variable. Now we'll just use what we know. We'll use the value that we just found, plug it back into the original equation. So let's use the top equation up here. So I've got 3 times x, but I know that x is negative 2. Plus 2y is equal to 4. So if I try to solve this for y, 3 times negative 2, well, that's negative 6, plus 2y is equal to 4. I can add 6 to both sides to cancel that 6, and I get 2y is equal to 10. Dividing both sides by 2, I get y is equal to 5. So I have my solution. I have negative 2 is going to be x, and 5 is going to be y. So I need both numbers, x and y, so my solution is an ordered pair of numbers. We used the first equation, so to check, let's plug these numbers into the bottom equation to make sure that everything is working. So the bottom equation was 2 times x plus y is equal to 1. So let's check. 2 times x plus y, this should be equal to 1, so let's check. 2 times negative 2, well, that's negative 4. Plus 5, negative 4 and 5 is 1. Good. And then we can also check the first equation, which should be this work over here. So we found our solution by picking an equation and is solving for one of the variables. In this case, it was pretty easy to solve for y. That's why I chose that one. And then I substituted that into the original equation, but the other equation. If I had plugged this back into the equation that I just solved for, the method wouldn't work. So be careful that you substitute it into the other equation. This is the substitution method of finding a solution. Let's look at the addition method. So this is maybe a little bit more complicated to describe, but when I go through the example, it will make more sense. So again, we have to write both of our equations in the form of ax plus by is equal to c. And the trick is that we are going to want either the x terms or the y terms to cancel. So before I do anything else, I want to go through an example where I show you what this means. So down here, I have two equations. 4x plus 5y is equal to 3, and 2x minus 3y is equal to 7. When we look at, let's use these x terms right here. 4x and 2x don't cancel. If we were to try to add them together, we would get 6x. So for the moment, these guys aren't canceling. What could I do to make those guys cancel? I'm going to leave the top equation alone for the moment. But the bottom equation, I'm going to take the entire bottom equation and I'm going to multiply it by -2. And there's a reason why I chose -2. Let's distribute this -2 everywhere. -2 times 2x, well, that's going to be -4x. -2 times -3y, that's going to be positive 6y. And -2 times 7 will be -14. Why did I choose -2? Well, now, when you look at the x values, 4x and -4x cancel. So, step 1 is to make sure that everything looks like something times x plus something times y is equal to something. The next step is to try to get things to cancel. So here I just multiplied this bottom equation by -2, and now the x values will cancel. Let's add these equations together. So 4x and -4x is going to be 0. They cancel, so I'm not even going to write anything here. 5y and 6y, that adds up to 11y. And 3 and -14, that adds up to -11. Well, this is pretty easy to solve for y. I can divide both sides by 11, and -11 divided by 11 is -1. Haha! I now know my y value, and I can plug that back into my original equation to get my x value. It doesn't matter which one I use, so I'll use the top one. So we have 4 times x plus 5 times -1 should be equal to 3. So let's simplify. For x, 5 times -1 is -5 is equal to 3. Add 5 to both sides. 3 plus 5 is 8. And divide both sides by 4 to get that x is equal to 2. So I have y and I have x. So my solution is going to be 2, -1. The last thing to do would be to check. So let's check using the bottom equation. I should check using both, but I'm running out of time. So let's just check the bottom equation. So we'll take 2 times the x value minus 3 times the y value. 2 times 2 is 4. -3 times -1 is 3. And that gives 7, which matches. So everything is hunky-dory.